Okay, so I just wanted to do a little sketch here to show what I mean by the trapezoid method for finding these area under the curve measures. So real quickly, I've just put down the data that was given to me at the different time, the blood draws and their blood concentrations. So 636, 597, 623, 506. Now the idea is we want to plot these on a graph that plots the time in hours on the x-axis and the concentration of the blood concentration on the y-axis. So we'll just do a quick sketch of this. Let's see, at time 0 it's 636, so put somewhere around there. At time 1 it's right at about 600, so put that. At 2 it's back up to 623, so a little close to what the first one was, and then finally at time 3 it's just above 500. Now the idea is that there's probably a smooth curve that attaches these, but we don't know what that curve is since we don't have blood draws in the time between 0 hour, 1 hour, and 2 hour. So what we do for our best approximation is we just simply attach straight lines to the points. And now the idea is that I want to find all of this area under the curve from 0 up to 3. So put a little dashed line down there. So how do I do that? Well, the trapezoid method, write that down real quick, says you take the data points that you have, so we have it for every hour, and you make trapezoids based on those times. So if you'll see, you now have 3 trapezoids. We'll shade them in red. We've got this trapezoid, we've got this trapezoid, and then we've got this trapezoid. And the idea is you want to find the area of this trapezoid, the area of this one, and then the area of this one, and then add them together. So Excel does this much better, but the basic idea, if you'll recall, is to find the area of a trapezoid. Let's draw one over here that just kind of looks like what we're dealing with. So let's say that this one has a height that we'll call y1, and over here it has a height of y2, and the width in this case is, let's just call it w. Then the area of the trapezoid is kind of like the area of a rectangle. In a sense, it's like if this were stretched into a rectangle, like if this was brought up and this one on the left was brought down, what would that be? Well, we'd simply find that by just taking the average of these two values. So we take the length of y1 and the length of y2 and divide them by 2, and then multiply that by the width. And that's how you would find the area of each. So, for example, let me scoot this down just a little bit. For example, if we were to find the first trapezoid, we would take the first value, which was, I've already forgot it, it was 636. And then we'd add the second value, which was 597, divide by 2, and then multiply by the width of the trapezoid, which is 1, so that's not going to change anything. And so we just pull out a calculator real quick, and 636 plus 597 is 1233. Divide that by 2, and that gives us an area of 616.5, and the units would be nanograms hours over milliliters. And we would just simply do that for this one, and this one, and then add them together, and that would give us our area under the curve. Now, I'm going to pause the recording in a second. We'll show you how we might do this on Excel. Okay, so now let's go over to a spreadsheet. So I'll pop over here. I've got one opened up. This will be close enough to what you would see with an Excel document. I'm going to kind of do the same table that I did before. I'm going to put time in one column, and I'm going to zoom in just a little bit on this so it might show up better on the video. There we go. We'll put the blood concentration in the next column and go from there. So the data was for times 0, 1, 2, and 3, and the concentrations again were 636, 597, 610, and 564. Oops. No, 506. I don't know what I'm doing there. There we go. Just lost it, sorry. Bring it back up here. Okay, now if you'll recall, switch back to the other screen real quick. If you'll recall, we were interested in finding the area of this trapezoid, and we found that by taking the two data points and finding their average and then multiplying by the width. So that's what we did for the first one. So what we need to do is automate that in Excel and let it do it much faster for us. So we'll scoot over there and see how we might do that. What I'm going to do is I'm going to make a new column that I'm just going to call trap for trapezoid. Now, if we have 4 data points, that gives us 3 trapezoids because we take pairs at a time. So we would have a pair of values for 0 and 1 that would then yield us 1 trapezoid. And then a pair 1 and 2 would yield us another trapezoid, and then finally the pair 2 and 3 would yield us the third trapezoid. So what I'm going to do is right here, beside the 597, I'm just going to put in a formula and do the thing that we did by hand a second ago. We'll say equals. Now I want to take the first value plus the second value, and then just find their average. And then again, I was going to multiply by the width. That's not going to change anything just by multiplying by 1. But in general, if your time stamps were not 1 hour apiece, then you'd have to put something non-trivial there. So I just do that, and you notice we get the same area of the trapezoid that we did before. But the nice thing is now is I can just simply drag this down, and that'll go ahead and compute the areas of the other 2 trapezoids. And then finally, to get the area under the curve, put AUC, all I've got to do is just add those 3 trapezoids together, and I've got my area under the curve statistic. Now you should be able to take this idea and go from there to do any kind of area under the curve that you want. So hopefully that helps. If not, let me know and we'll figure something else out.